In this video, we are going to be looking at how to find the nth term of a quadratic sequence. If you haven't done so already, go back and look at the nth term of linear sequences video that I made earlier. A linear sequence looks like this, an plus b, and it's when you're going up by a constant amount. So for example, 3, 5, 7, 9, and so on. A quadratic sequence looks like this, an squared plus bn plus c. And the difference is now that we're not going to be increasing our value by the same amount, but our numbers are going to increase by a difference that is increasing by the same amount. So for example, if we go up by 2 to start with, and then we go up by 4, so that would give me 9, and then we go up by 6, so that would give me 15, and then we go up by 8, which would give me 23. This sequence, 3, 5, 9, 15, 23, is a quadratic sequence. I'm going to now show you how to find the values of A, B, and C. There are many different ways to do this, but my trick is really, really easy, and it's almost guaranteed to get you full marks. As long as you follow the algorithm through every single time, you'll definitely get full marks. So let's take my numbers, 3, 5, 9, 15, 23. We always find the first difference, which I've just done. So we go up by 2, 4, 6, and 8. That's my first difference. My second difference is always going to be the same. It's always going to be 2. Different patterns will have different second differences, but as long as the second difference is the same, that means you are looking at a quadratic sequence. Whatever this number is, halve it. Half of 2 is 1. If it was 6, it would be 3. If it was 10, it would be 5. This is your value for A. So A is 1. A is always half the second difference. Now, to find the value of C, that's the C that's here, what we're going to do is we're going to go back one term in the sequence. To do that, we just need to think about our first differences. It goes 8, 6, 4, and 2. So the next gap back would be 0. If the next gap back is 0, that means that this number here is 3 as well. And whatever that term there is, that is C. So in this case, C equals 3. So what do I know so far? Well, I know I have an squared plus bn plus c. And I know that a is 1. So I have n squared. I don't know b, but I know that c is 3. So I have n squared plus bn plus 3. And the trick, this is the best bit, this is the easiest bit, is to look at the first term in the sequence. This will always be the value of a plus b plus c. A is 1, c is 3. So I can form an equation. A plus b plus c is 3. A is 1. I don't know b, but I know that c is 3. Solving that, you get b equals minus 1. And therefore, my quadratic sequence is n squared minus n plus 3. That is the nth term of a quadratic sequence. Now this trick works every single time. So a is half of the second difference, c is the term before the 0th term, b is whatever it makes to get the first term when you have a plus b plus c. Let's have another example. Let's go 8, 19, 36, 59, 88. So from 8 to 19, I go 11. From 19, that means that this gap here has to be 5, because 11 take away 6 is 5. So therefore, this number here, the C, is 3. So I have A equals 3, and I have C equals 3 at the moment. Remember the trick? The first term in the sequence, which is 8, is A plus B plus C. Therefore, 3 plus B plus 3 is 8. That means that B equals 2. And therefore, the nth term of this quadratic sequence, 8, 19, 36, and so on, is 3n squared plus 2n plus 3. That is the nth term of this quadratic sequence. And that's always the way. That's how you find the quadratic sequence nth term. Half the second difference to find a. C is the 0th term. Go back one term. B is whatever you need to get the first term when you add a plus b plus c together.